Hi there. So we want to look at how to use our conic flowchart. So because a lot of the conic equations actually end up looking really similar to each other, the idea here is use this flowchart, ask these questions, and then that'll help you determine exactly what your shape looks like. So let's say, for example, you have the conic x squared minus 6x plus y is equal to 0. Okay? So the first question that you want to ask when you see this is this question right here that says, are both x squared and y squared present? If they are, you move on to the second question down here. But if not, which in our case, they're not, right? We only have x squared, we don't have y squared, so for us that's a no, and we look at, oh, that means that this is a parabola. So similar to that, let's grab another question. Let's look at 4x squared minus 8x plus 9y squared minus 36y is equal to 4. Okay? Okay. So looking at this one, again, we run through the same set of questions. So first question, are both x squared and y squared present? Yes, they are. So that means we go this way and we look at our second question. Do x squared and y squared have the same sign? So I'm really focusing on x squared and y squared here. They are both positive. So again, yes. Now we move to question 3. Do they also have the same coefficient? Well, this first coefficient's a 4 and this one's a 9, so our answer is no, which means this is an ellipse. Okay, I'm gonna backtrack a bit here. Okay, let me give you a couple more examples. Let's see what I can find here. How about y squared plus 6y minus 4x squared plus 8x is negative 6. So again, we go through our same round of questioning. Are both x squared and y squared present? Yes. Okay, so we go down here. Do x squared and y squared have the same sign? No, because this is a positive y squared and this is a negative 4x squared. So no tells us this is a hyperbola. So hopefully you kind of get the idea of this. I can look for one that's a circle. So we could also do one like this, 6x squared minus 12x plus 6y squared minus 18y plus 25 is 0. So again, let's start with our first question. Are both x squared and y squared present? Yes. Okay, so we go down to the next question. Do they have the same sign? Well, yes, because this is positive. This is also positive, right? We can throw a little plus sign in there. So yes. Do they have the same coefficient? Well, that's a 6 and that's a 6. So also yes, which means this is a circle. Okay, so lots of scribbling all over this page, but again, you can print this out or you can make a similar sheet, whatever works really well for you, so that you can remember what's what. Now, the other thing I want to show you is at the bottom of this, you have spaces to write each of your equations. Okay, so what I would recommend that you do is you write out the actual equation for each of these, and you can rename this, right? Adjust this sheet so that it fits your needs. Our vertical equation, we have, maybe you split into at 0, 0, right? That would be x squared is 4py, or you can remember at hk, right? Because if h is 0 and k is 0, we go back to this. So sometimes it's helpful just to memorize the quote-unquote more complicated one, x minus h squared, 4p, y minus k squared. If we plug 0 in so that we're at the origin, you'd have x minus 0 squared, 4p, y minus 0. This should not be squared, this should just be regular. You get left with, this is just x squared, 4p, and this is just y. So you could choose just to remember this equation and know that if you plug in 0, 0, it goes to this one. Again, move forward in whatever way makes sense to you, but this is a place for you to make some good notes about these vertical parabolas. You can draw a sketch of a graph, right? What does this vertical parabola look like? You can call this H and K. Where is your focus? Where is your directrix, right? You can leave yourself all these notes. You have this axis of symmetry. Lay out whatever information is helpful for you. You have another space for the horizontal one. You also have room, this page is sideways, but you also have room for circles because that one's just kind of its own unique thing. You have ellipses, vertical and horizontal, and you have hyperbolas, vertical and horizontal. I don't fully know why this got turned around, but that's a fairly easy fix. I'll fix it on your Canvas page, and you can do the same exact thing for circles, ellipses, and hyperbolas, and their formulas. Okay? See you in the next one.